SQL injection has been on the OWASP top 10 list for over a decade. It has caused some of the largest data breaches in history. It is one of the most well-documented vulnerabilities in existence. And it is still being found in production applications every single day. That tells you something important. Understanding what SQL injection is and writing secure code to prevent it are two completely different things. Development teams know it exists. They still ship it. Which means QA engineers need to be testing for it. Here is the basic idea. Most web applications store data in a database. When a user submits a form, searches for something, or logs in, the application builds a database query using that input. If the application does not properly sanitize the input before including it in the query, an attacker can inject their own SQL code. The application thinks it is building a query. The attacker is rewriting it entirely. The consequences range from reading data the attacker should not see, to deleting entire tables, to bypassing authentication completely. In this episode we are going to cover how SQL injection works mechanically, how to test for it manually using Burp Suite, how to use SQLMap for automated detection, and how to write test cases that can be run as part of your regular regression suite. By the end you will know exactly what to look for, how to find it, and how to document it. Let me explain how SQL injection works with a concrete example. Suppose your application has a login form. The user enters a username and password. The application builds a database query that looks like this: select star from users where username equals the value the user typed and password equals the value they typed. If that query returns a row, the user is authenticated. Now imagine an attacker types this as their username, admin single quote or 1 equals 1 double dash space. The application takes that input and builds this query: select star from users where username equals admin or 1 equals 1 double dash, and then the rest of the original query is commented out. 1 equals 1 is always true. So the query returns a row. The attacker is authenticated as admin without knowing the password. This is a classic authentication bypass via SQL injection. And it works because the application trusted the user's input and included it directly in the query without sanitization. The fix is parameterized queries, also called prepared statements. Instead of building the query string by concatenating user input, you use placeholders. The database driver handles the escaping. User input can never be interpreted as SQL code. This is a solved problem. The solution has existed for decades. And yet injection vulnerabilities keep appearing because developers are in a hurry, because legacy code is not refactored, because someone used string concatenation out of habit. That is why testing matters. Code review catches some of it. Automated security scanning catches more. But manual testing with real injection payloads catches things both of those miss. Let us look at how to test for SQL injection manually. First, identify every input field in your application. Search boxes, login forms, registration forms, profile editors, URL parameters, filter dropdowns, anywhere the user provides data that might be used in a database query. For each input, start with the simplest possible test, a single quote. Just type one single quote and submit. Look at what happens. A well-built application will either reject the input with a validation error or handle it gracefully. A vulnerable application will often throw a database error. You might see something like syntax error near quote, or an unhandled exception with a stack trace, or a 500 internal server error where you previously got a 200. Any of those error responses is a signal worth investigating further. If the single quote causes an error, try a classic or 1 equals 1 payload in a search field. If the search returns all records instead of filtered results, you likely have a SQL injection vulnerability. For login forms, try the payload I described earlier, admin single quote or 1 equals 1 double dash. If it logs you in without a valid password, that is critical severity. Use Burp Suite Repeater to run these tests systematically. Intercept the login request, send it to Repeater, modify the username field, and send it with different payloads. You can do dozens of variations in minutes. Document every payload you tried, the expected response, and the actual response. Even if you do not find a vulnerability, that documentation proves you tested for it. Manual testing is essential for understanding SQL injection, but automated tools can cover far more ground faster. The most widely used open source tool for SQL injection testing is SQLMap. SQLMap is a command line tool that automatically detects and exploits SQL injection vulnerabilities. You give it a URL and it tests dozens of injection techniques and database backends automatically. To use it on a login form, you first capture the login request in Burp Suite. Right-click the request and save it to a file. Then run SQLMap with that request file. The basic command is SQLMap- followed by the path to your saved request file. SQLMap will test each parameter in the request for injection vulnerabilities. It will try different techniques: error-based injection, Boolean-based blind injection, time-based blind injection, union-based injection. If it finds a vulnerability, it will tell you exactly which parameter is vulnerable and what technique worked. Important note on authorization: only run SQLMap against applications you own or have explicit written permission to test. Running it against a production application you do not have permission to test is illegal. Use it in your test environment, against a staging server, or as part of a formal security testing engagement. In your CI pipeline, you can include SQLMap in a dedicated security stage that runs against your staging environment after deployment. Configure it to exit with a non-zero code if it finds vulnerabilities, which will fail the build and alert the team. This gives you automated regression testing for SQL injection with every release. Let us talk about writing SQL injection test cases that work as part of your regular test suite. The goal is not to run a full SQLMap scan in CI. That takes too long and creates too much noise. The goal is targeted test cases that check specific injection points you have already identified as high risk. A good SQL injection test case has 4 parts. The target, which endpoint and which parameter you are testing. The payload, the specific injection string you are sending. The expected behavior, what a secure application should do, usually return a 400 error or a validation message. And the failure condition, what indicates a vulnerability, usually a database error, unexpected data, or successful authentication without valid credentials. For a login endpoint, you might write 3 test cases: one that sends a single quote as the username and expects a 400 response, one that sends the or1=1 bypass and expects authentication failure, and one that sends a known valid username with a SQL comment as the password and expects authentication failure. These are fast to run. They do not require SQLMap. They can run in your existing test framework using plain HTTP requests. If any of them passes when they should fail, you have caught a regression. Something changed in the codebase that reintroduced a vulnerability. The key insight is that SQL injection test cases are not special. They are just negative test cases with security payloads instead of business logic edge cases. Same structure, same tooling, same reporting. Add them to your regression suite. Run them every sprint. Treat a failure the same way you treat any other critical bug. Here is what we covered in this episode. SQL injection happens when user input is included directly in a database query without sanitization. The attacker can rewrite the query entirely, bypassing authentication, reading unauthorized data, or destroying data. The fix is parameterized queries. But despite this being a solved problem, SQL injection keeps appearing because of legacy code, rushed development, and lack of testing. Manual testing starts with a single quote. Any database error is a signal. Use Burp Suite Repeater to test variations systematically. SQLMap automates injection detection across dozens of techniques and database backends. Use it against your test environment with explicit authorization. Add SQL injection test cases to your regression suite. They are just negative test cases with security payloads. They catch regressions before they reach production. Next episode we are covering authentication and authorization testing. How to test login flows for bypass vulnerabilities, how to test session management, and how to probe JWT tokens for common weaknesses. These are the bugs that let attackers take over user accounts. They are also some of the most commonly found vulnerabilities in modern web applications. Subscribe to QA Career Lab. New episodes every day. I will see you in the next one.